Hello everyone, welcome to Ask Geology, a whole new way to understand our Mother Earth. So in this today's 7-minute numerical class, we'll be discussing about one numerical related to your geochemistry, and this is going to be the first numerical in geochemistry. Okay, so the question is, a radioactive nucleus, that is X, decays to Y. Okay, then within the decay the number of alpha and beta particles emitted during this decay are. Okay, so we know from a radioactive nucleus, okay, a radioactive nucleus, let let this to be X, this is 92 and 290. Okay, so this is one radioactive nucleus, and we know that radioactive nucleus are very unstable, and to gain that stability they decay. Okay, and this decay process that basically happens with the help of your emission of your alpha and beta particles. Okay, gamma is basically, that is one simple radiation of our electromagnetic spectrum. So alpha and beta particles, these are very important particles which are get emitted when one radioactive nucleus, very unstable radioactive nucleus, that decays and it gets a stable nucleus. Okay, gets a stable nucleus, and if it doesn't get a stable nucleus and it further disintegrates, okay, so there are so many branches, okay, branches of your radioactive decay. If you see the uranium thorium, okay, uranium lead, there are so many branches, okay, there is a series of decay. Okay, simply you can see that here you can see this is the mass number. If it is the atomic symbol means this is the atomic symbol of your element. Okay, and this Z is your atomic number, and this atomic number basically represents of your number of proton. P plus means number of protons, and this mass number, it basically is the sum of your number of protons and neutrons. Basically this is the mass number. Okay, and you can see that proton has a positive charge, neutron is neutral. So this 290, this is actually basically comprising the mass of your proton plus of neutron, and this lower one, this is your atomic number, basically it represents the number of protons. Okay, now this X radioactive nucleus, very unstable radioactive nucleus, now it is decaying to, and it is getting to Y. Okay, this Y is stable, then this is 87 and 278. Now he is asking number of alpha and beta particles. So in alpha particles we know that is 2 and 4, plus of beta particles, for beta particles that is minus of 1 and 0. Okay, so alpha, this is more similar to helium, so it has a atomic number of 2 and mass number of 4. And in beta particles the atomic number is -1 and it has no mass number. Okay, so this is basically your, this is basically the equation. Okay, and if you just solve the equation, then we'll be able to know the number of alpha and beta particles. Okay, so let this alpha, okay, this is, let me rewrite again, 290x 92, now it is giving to, this is 278 87, plus of X number of alpha particle, this is 24, plus of Y number of beta particles, -1 and 0. So simply you just make one equation. Okay, so just add up the upper and the lower. Simple. For the upper portion, what we will get, 290 is equal to 278 plus of 4x, and this is 0 plus of 0y, so no value to add this one. Okay, so simply we can get 4x is equal to 290 minus of 278. What is that value? 290 minus of 278, it is equal to 12. That implies x is equal to 3. then this is x. X is your number of alpha particles. This is your number of alpha particles. Okay, so the number of alpha particles is 3. Now just make a equation with the help of the lower one. Okay, that is 92 is equal to 87 plus 2x, then minus 1, that is minus y. So we have value 92 is equal to 87 plus of 2 cross of x is 3, so this is equal to 6 minus of y. So if we just take this y this side, then 87 plus of 6, what is the value? 3, 9, 93 minus of 92 is equal to 1. This one is number of gamma particles, sorry, number of beta particles. Okay, so what is our answer? Answer is our 3 alpha particles and 1 beta particle. So just see, yes, 3 alpha particle and 1 beta particle. This is your answer. So here I just want to add simple, very simple question. Okay, alpha particle I am okay with that, but in this beta particle my question is whether it is beta positive or beta negative, or it is positron or negatron decay. This is one question to all of you. Okay, simply whatever I just described, that is basically written here. I will be explaining this this slide again, okay, in a different session, but this thing you just remember that this upper person you just add up, this lower person you just add up, number of x, that will give your number of alpha particles, and number of y, that will give you the number of beta particles, x, number of alpha particles. So simply we can say that this 4x plus of this one, whatever, you just sum of the upper one. This is 293 is equal to 214 plus of 4 of x, and x, it is the number of alpha particles. And in the lower portion you just simply 92 is equal to 82 plus of 2x minus of y, you can see this minus 1. Okay, and this number of beta particles, that will be your y. Okay, this is a simple diagram that is describing the various if number of proton, okay, sorry, number of neutron, and your z. What is the z? This is the number of proton, or simply the atomic number. If they are varying, okay, then we will get isotope here. Isotope means the z will be fixed, but the number of neutrons will vary. We will get isotopes. This is isotone, where the number of neutrons will be same, but different number of protons, different atomic numbers, that will be isotone. Then isobar, isn't it? And we can see that positron and negatron. Okay, I'll be explaining these in details in a different class, no problem. But you can see that if it is the parent atom, if it is coming this side, then this is supposed to just experience this beta negative, beta positive, and positron is more or less similar to your electron capture. What is electron capture? I'll be explaining in the next or in the coming session. Okay, alpha particles, you can see that two numbers of, isn't it? This is neutron, this is proton. If it is loses one neutron, then it will come down. If it is losing one proton, then it will come to the left. Okay, and there are rubidium, strontium, uranium, thorium, Sm and D. Okay, potassium, argon, potassium, calcium. What types of decay there? Whether it is beta decay. If it is beta decay, then what is it? It is positron and negatron decay. Okay, uranium, thorium, Sm and D. Alpha decay. Okay, electron capture. This electron capture, related to this electron capture, there are so many of questions they have been asked in GATE, isn't it? So let us see. This is our answer. This is the 3 alpha and 1 beta. And thank you all. And if you guys are very interested to join our group, you can just text to these numbers, or just put a simple mail, or you can click to the links which are given below in the description box. Thank you.